All right, 7.6, surface area of pyramids. So the difference between a prism and a pyramid. A prism had two of the same shapes and they were connected by rectangles. Pyramids are like the Egyptian pyramids where we have a base that is some shape and then they are connected completely by what shape? Triangles up to a point, okay? So who would like to read the learning target? Eben.
I can draw nets and use nets to find the surface area of the pyramid.
Very good. Okay, so here is a pyramid. This is what it looks like when we unfold it. That is called a net. So we have a base of a square in this case, and then we have four what shapes? Triangles, okay? In this book, so in 6th grade math, the base of every pyramid you will see will either be a square or an equilateral triangle. That means all three sides are equal. And what that means is that all of the triangles that come up out of the base are going to be identical, which is nice because you don't have to find the area of each one. A reminder, a square pyramid is a pyramid with a square base. A triangular pyramid is a pyramid with a triangular base. All right, here we go. We're going to find the surface area of a square pyramid. So how many faces are on a square pyramid? Eben? 5. We have the base, and then we have how many triangles? 4. So we're going to find the base of this pyramid, and then we're going to find the 4 triangles. So everything I write down, you should also be writing down. Okay, so the base is what shape? It's a square, which means if this length is 7, what is this length right here? 7. So we're going to do 7 times 7, which gives me 49. Okay, then our triangles. How do we find the area of a triangle? Very good. Base times height divided by 2. So what's the base? 7. What's the height? 10. And then we divide it by 2. What is 7 times 10? Divided by 2? 35. Okay, so one triangle is 35. How many triangles are there? 4. So what should I multiply this 35 by? And then what do I get? 140. Okay, am I done?
No.
What's my final step? Add the base area plus the sides, and what do we get? Oh, my pen's dying. What is it? Meters squared. Goodbye, pen. I bought erasable pens, but the ink runs out so fast. Okay, next one. What is the area of the base of this, or sorry, what is the shape of the base for this pyramid? Who said that? Oh, okay. I thought that was Mrs. Campbell. I was like, Mrs. Campbell, what the heck? Okay, so we have the base, which is a triangle. And then how many sides do we have coming up out of the base? 3. So we have 3 triangles coming up out of the base. Okay, so let's find the area of the base. What is the length of the base of the triangle on the base? 6 times the height. What's the height? 5.2. So we're just looking at this base one right here. So 6 times 5.2, and then we divide that by 2. So normally we would get really overwhelmed looking at this and seeing the decimal, but instead we're going to use a calculator. So 6 times 5.2 is 31.2, and then divide that by 2, and we get 15.6. Is that what you guys got? Okay, so there's our base. Circle that. And then we have our 3 triangles that are coming up out of the base. What is the length of the base of those triangles? So looking right here, what's this? 6. Yes. And then times the height. What's the height of those triangles? Okay, and since they're triangles, we then divide them by 2. What's 6 times 8? divided by 2. Okay, so we got 24. Is that the answer? No, because that's only one of the triangles. How many are there? 3 of them. So we're going to multiply this by 3. And we get, 72. Okay, then what's our final step? Add the base plus the 3 triangles. I put the wrong thing in. Yep. 87.6 feet squared. All right, how are we feeling about this? It's similar to what we did last week, isn't it? It's just a matter of identifying how many sides there are and finding the areas of all of them. Okay. Let me stop this.